Welcome back, ladies and gents. This is Mrs. Cardwell here with our math lesson for the day. Today we're looking at Unit 1, Session 1.2. We're identifying properties of numbers. First thing we're going to do is we're going to look back to your math book, pages 1 and 2. Now this was part of your schoolwork and homework last night. Page number 1, we were looking at our number puzzles. These ones were called One Clue. All right, now I want you guys to go ahead and look at number 3 down here. This number of tiles will only make one array. Now, one of our students mentioned that the number of tiles 7 would only make one array. So we're going to be exploring that for just a moment. So we're going to look back to our math pages and what are some examples of numbers that only have one array? As we mentioned before, 7 is one of those numbers. But also, let's go ahead and think about, what about the number 3? We can create an array that is 3 by 1, or 3 times 1. It's the only way we can arrange an array with 3 tiles. So thinking along these lines, let's go ahead and let's take a look at 5. 1, 2, 3, 4, 5 tiles. Okay, now remember our arrays need to be rectangles. They need to be straight, right? We can't have sort of a pyramid kind of thing like 2 on the bottom and 1 on the top, right? They have to be straight rectangles with an equal amount on the side and on the bottom, right? We can't just have one here and then the other juts out. So this is 5 times 1, right? There's 5 going along this way and 1 going along the height. So 5 is also a number that can only have one possible array. All right, let's go ahead and look at another number. Now you may notice that these numbers are odd numbers, right? So let's see if other odd numbers help us out. What about the number 7? 1, 2, 3, 4, 5, 6, 7. We can only get an array with 7 using 7 times 1. 5 times 1. 3 times 1. Okay, so let's go ahead and let's think about these numbers. There is actually a special name for these numbers, and we mentioned it a little bit the last time that we met. All right, so just wanted to check in with you guys. Whenever we have a number that has factors, the only two factors, the two numbers that make it up are the number itself multiplied by 1. That is a prime number. And as I just mentioned, we'll go ahead and underline that as it's a definition. A prime number is a number that only has 2 factors, or it's made up of 2 factors. And those 2 factors are 1 and itself. And what we mean by itself would be 7 or 5 or 3. We can only get 7 by going 7 times 1 equals 7. All right, so those are our prime numbers. Now there's if a number is not a prime number, it is what we call a composite number. And a composite number has more than two factors. And I'm going to give you some examples. So our definition, a composite number is a number with more than two factors. Okay? So our prime numbers are above. If it was a composite number, we could have a number like the number 16. Okay? So 16, there are a couple different ways I can build an array to make 16. We talked about it just the other day. So if I go 2 times 8, 1, 2, 3, 4, 5, 6, 7, 8, we know that 8 times 2 equals 16. So that's one way we can find that. Another number that creates 16 would be 1, 2, 3, 4 times 1, 2, 3, 4. 4 times 4 is also 16. So now that we know that 16 can go into these different numbers, or these different numbers can make up 16, we can also do one that looks like this. 1 times 16 is 16. Okay? So we know that 16 is a composite number because more than two factors make that up. 1 and 16 are some factors that make up 16. 4 times 4 also makes 16. 8 times 2 also makes 16. So now we know that is a composite number. All right. There are also some very special numbers. And taking a look at this particular one, you'll notice this is a perfect square. And perfect squares make me think of our square numbers. Okay, so our square numbers are numbers that have the same digit factors. And when I get into the examples, I think you'll see it a little bit better. So the reason they call these square numbers is that they create a perfect square. Just up above, I have 4 times 4. So 4 times 4 equals 16. 16 is a perfect square because if I draw it out in an array, 1, 2, 3, 4, 1, 2, 3, 4, it creates a perfect square. All sides are equal. Okay? Now, there are many other numbers that multiplied by themselves create perfect squares. For example, we have 2 multiplied by 2 equals 4. So if I come, oops, let me scooch this down just a little. 2 across, 1, 2, and 2 down. This is a perfect square too, right? So 16 is a perfect square. 4 is a perfect square number. Let's think of some other ones. What if we went 3 across and 3 down? This is a perfect square as well. 3 times 3 equals 9. And if I'm ever unsure, I can always count up 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect square. Similarly, 5 times 5. We'll go across 1, 2, 3, 4, 5, and down. 1, 2, 3, 4, 5. Okay, if you were to count up all the tiles in there, 5 times 5, it is 25. Okay, so all of these are square numbers. You'll notice that some of the numbers that looked like they were prime, like 3 up above was a prime number. However, when you multiply it by itself, it becomes a square number. Okay? So square numbers are 4, 9, 16, 25. Okay? Those are our square numbers. All right, moving right along. Now we're going to go ahead and take a peek at some more array problems. These ones are number puzzles with 2 clues. All right, so we're going to go ahead and take a look at page 7. I've written our page number up here, ladies and gents, and today we're going to be looking at number puzzles with 2 clues. As always, we start at the very top. We read all of the instructions thoroughly to make sure we're doing what we're being asked. So for each number puzzle, follow these steps. A, find 2 numbers that fit both clues. B, draw unmarked arrays and label the dimensions to show that your number fits both clues. C, list other numbers that could also fit both clues. Okay, so let's go ahead and take a look at number 1. All right, so this number of tiles will make an array that is 2 tiles wide. So we know, actually you can see it peeking through the bottom part, we know that one of our arrays is going to need to be 2 tiles wide. Okay, and then it also says that this number of tiles will make an array that is 4 tiles wide. So we have a second array here, and this one needs to be 4 tiles wide. So remember, even though this is 2 on one side and this is 4 on another side, we need to find a number that fits, that is the same on the inside. Okay? All right, so let's go ahead and take a look. So for this array, 2 times something needs to be the same number as 4 times something. So I'm going to go ahead and think about it. I'm going to go ahead and try a number out. So we have 2. Let's try 2 times 6. 2 times 6 is 12. 2 times 6 equals 12. All right, now we have 4. I'm wanting to find the same number on the inside. 4 times what is 12? Okay, we think of 2 of our multiples. 4 times 2 is 8. 4 times 3 is 12. 4 times 3 equals 12. All right, so as you can see, this satisfies both of these clues. This number of tiles will make an array that's 2 tiles wide. 2 times 6 is 12. And this array of tiles will make, this number of tiles will make an array that's 4 tiles wide. 4 times 3, which is also 12. Okay? Now remember, they don't both have to be 2 on either side, right? So one of the numbers that will work is 12. And these are 2 different ways of showing or demonstrating 12. All right. Okay, let's go ahead and see if we can find another number that works for this. Again, we need for one of the arrays to have a 2 in it. The other array needs to have a 4 in it. Okay? So thinking about these things, we know that 2 times 2 equals 4. And then we can have 4. What would equal 4 for this one? 4 times 1. 4 times 1 equals 4. We have 4 on the inside of this one. 2 times 2 is 4. 4 times 1 is also 4. So this is another number that will work. Okay? And now it's your opportunity to start drawing more arrays and seeing if you can fit. Remember, it needs to have 2 on one side and 4 on the other. Okay, and these are 2 separate arrays. All right. Okay, ladies and gents, so go ahead and give it a try and see if you can find other numbers to fit these clues. And I will see you in class.